Biological evolution on Earth has operated for over 3 billion years under a single, relentless directive: energy efficiency. For most species, survival means running faster, biting harder, or secreting lethal venom. But when predator pressure reaches extreme levels, the engineering of life adopts a strategy far more unsettling than physical violence. It erases the living being's presence from reality, distorting animal anatomy until it transforms into pure, inanimate geometry. To the eyes of an untrained observer, they are invisible. To science, they are the mechanical engineers of absolute disguise. Welcome to Nature's Top 10. Today, we're going to explore 10 creatures that disguise themselves as inanimate objects with terrifying perfection. And our journey begins on the damp, shaded floor of the Southeast Asian rainforests, where an amphibian chose to redesign its own head to vanish among the remnants of decaying organic matter. Native to the rainforests of Malaysia, Thailand, and Indonesia, the Malayan horned frog is a masterpiece of passive camouflage. Hiding on the floors of dense jungles, this amphibian challenges the standard anatomy of its species by adopting sharp triangular projections on its snout and above its eyes. These structures mimic the torn, dried edges of a dead leaf with millimeter precision. The visual mechanics are so refined that a continuous dark line runs across the animal's back from end to end, perfectly replicating the midrib of a fallen leaf. Its flattened body eliminates the biological curves that would otherwise betray its presence to predators. The frog remains perfectly still for hours, becoming completely indistinguishable from the carpet of organic matter around it. It is an anatomical engineering feat designed for total erasure. But while this amphibian on the forest floor uses lines and skin folds to resemble a dead leaf on the soil, up in the tree canopies of the exact same region, a winged insect took this disguise to a dynamic level, flashing two completely opposite visual realities within a single body. Found in the tropical regions of Asia, from India to Japan, the deadleaf butterfly operates one of the fastest mechanical tricks in the animal kingdom. When in motion, it displays the classic visual signature of a tropical insect with upper wings covered in vibrant shades of deep blue, bright orange, and white spots. It is a chromatic pattern designed to signal its presence. The real shock happens the moment it lands. The instant it closes its wings, the colorful biology vanishes to make way for a perfect replica of a dry, withered leaf. The design on the outer side of its wings is terrifyingly realistic. The lower tip perfectly mimics the petiole, the tiny stalk that connects a leaf to a branch, while dark markings simulate mold spots, fungi, and even small holes caused by insects. By closing its wing structure, it erases its visual identity in less than a second. But while this butterfly relies on the static closing of its wings to fool predators on the tree, a close relative in the insect world from Asia and Australia decided that anatomical disguise wasn't enough. To vanish completely, it had to learn to mimic the laws of atmospheric physics itself. Scattered through the dense rainforests of Southeast Asia and parts of Australia, insects of the genus Phyllium have pushed the engineering of disguise far beyond texture and color. The bodies of these animals do not just mimic a green leaf in the process of decaying, complete with symmetrical brown spots on the edges that replicate fungal damage and lines that perfectly trace plant veins. The true secret to their survival lies in their movement. To bypass the visual tracking of birds and lizards that hunt by detecting motion, the walking leaf synchronizes its biology with the laws of atmospheric physics. When the wind blows through the canopy, the insect begins to rock its body from side to side in a rhythmic pattern. It doesn't do this to travel, but to simulate the natural oscillation of a real leaf trembling in the breeze. It is a behavioral camouflage mechanism that completely confounds a predator's spatial analysis. But while this insect moves to mimic vegetation and escape death, A species from the same order in the jungles of Malaysia completely inverted this logic. It uses the delicate design of a flower not to hide, but as a fatal trap to lure its victims straight into its jaws. In the tropical rainforests of Malaysia and Indonesia, the orchid mantis shatters the rule that camouflage is strictly a defensive game. This insect operates what science calls aggressive mimicry. Instead of blending into dead leaves to disappear, it displays brilliant shades of white and hot pink to stand out in the vegetation, turning its anatomy into a surgical replica of an orchid flower. The mechanics of its disguise are purely offensive. Its hind legs have evolutionarily expanded into wide, flattened lobes that perfectly mimic flower petals. The level of biological engineering is so absurd that the insect can reflect ultraviolet light in the exact same way real flowers do to attract pollinators. Butterflies and bees fly directly toward what they believe is a food source, only to be snapped up in milliseconds by concealed, serrated claws. It doesn't just fool the eyes, it hacks the very instincts of its prey. But while in the density of the rainforest life masquerades as delicate petals to hunt in the air, in the depths of the ocean, evolution had to discard soft shapes. Down there, to survive, living flesh must transform into the chaotic rigidity of a coral reef. Inhabiting the shallow reefs of the Indian and Pacific Oceans, the tasseled scorpionfish utilizes its disguise to operate a hunting method based on zero active energy. This predator spends entire days completely motionless on the seabed, saving energy by never swimming. Evolution stripped its body of the smooth lines that would normally betray a fish's silhouette, replacing them with the chaotic roughness of the marine terrain. The mechanics of its survival mode rely on a contour-breaking camouflage. Its skin is covered in fleshy tassels and filaments that perfectly mimic the actual growth of algae and coral tentacles. When a smaller fish or shrimp swims just inches away, it cannot distinguish where the rock ends and the predator begins. The scorpionfish waits for the prey to enter its strike zone and in a split-second movement snaps its massive jaws open so fast it creates a hydrodynamic suction vacuum, swallowing the victim whole before it ever realizes the danger. But while on the ocean floor survival requires a predator to look like rough stone for an ambush, just a few meters away, evolutionary pressure miniaturized life to the absolute extreme, forcing a defenseless creature to match its host's texture just to avoid becoming a meal. In the deep waters of the Coral Triangle in the western Pacific Ocean, survival demands radical miniaturization strategies. This is home to the pygmy seahorse, a creature measuring less than 2 centimeters in length. Unlike its larger relatives, this animal lacks the speed to flee from predators and has zero physical defenses against hunting fish. Its survival mode relies exclusively on an absolute textural symbiosis with a single organism, the sea fan, a specific type of colonial Gorgonian coral. The mechanics of its disguise are so extreme that the seahorse spends its entire life anchored to the branches of this coral. To vanish from sight, its body develops red or yellow calcified bulbs and nodules that precisely replicate the size, color, and shape of the host coral's living polyps. This mimicry is so perfect that the animal doesn't just fool a predator's eyes, it fuses its physical presence into the marine colony. If it detaches from the coral for even a few seconds, its survival barrier collapses and it is instantly devoured. It survives by being, quite literally, a living extension of the reef. But while in the deep ocean, survival requires a tiny body to become an extension of a coral to avoid being hunted, high in the trees of the Brazilian rainforests, this strategy of static rigidity was adopted by a bird that transforms its own flesh and feathers into dead wood. In the forests and savannas of South America, with a heavy presence in Brazil, the common potu operates one of the most striking survival modes in avian biology. As a nocturnal bird with broad wings, it spends the entire day exposed to sunlight, which would normally make it an easy target for hawks and falcons. To survive this vulnerability, the potu does not hide in hollow trees. Instead, it perches on the tips of dead branches or wooden fence posts and triggers a state of absolute muscular rigidity, turning itself into an inert extension of the tree. The mechanics behind this disguise rely on a unique anatomical adaptation in its eyelids, known as a magic eye. The potu stretches its neck upward, points its beak toward the sky, and closes its eyes to eliminate the glossy spheres that would otherwise betray its animal nature. However, its eyelids feature tiny vertical slits that allow it to continuously monitor its surroundings even when its eyes are fully shut. It tracks predator movements in a 360-degree radius without moving a single muscle. It survives by simulating dead wood while secretly watching the world. But while in South American forests a bird turns into a dry vertical stump to endure the day, in the tropical jungles of Madagascar, evolution took that same concept of dead plant matter and twisted it into creating a reptile that mimics organic decay in a terrifying way. Isolated from the rest of the world on the island of Madagascar, the satanic leaf-tailed gecko developed a survival mode entirely based on the detailed imitation of plant death. This small nocturnal reptile spends its days hanging from low branches or resting on the forest floor, completely vulnerable to birds of prey and snakes. To avoid becoming a meal, it doesn't rely on speed. Its body has been geometrically shaped to look like a dry leaf that has been twisted and withered by time. The mechanics of its disguise focus entirely on the details of organic decay. Its tail is flattened and features semicircular notches along the edges that perfectly reproduce the damage caused by chewing insects. Its skin displays lines that mimic plant veins alongside dark brown hues that simulate fungi and tissue necrosis. Furthermore, spine-like projections above its eyes break the silhouette of its cylindrical head. It survives because the optical systems of its predators register its presence as nothing more than useless forest debris. But while in the undergrowth this reptile camouflages itself by mimicking a dry leaf on the ground, a direct relative from its same genus took contour-breaking camouflage to vertical tree trunks, manipulating the physics of light to eliminate its own shape. Still within the rainforests of Madagascar, the mossy leaf-tailed gecko operates one of the most complex survival modes in biological physics. Unlike its relative that mimics leaves on the ground, this lizard spends its days pressed vertically against tree trunks. On a flat, exposed surface, any contour on an animal's body would cast a telltale shadow under the sunlight, instantly betraying its three-dimensional presence to hungry predators. To survive there, it had to learn to hack the behavior of light. The mechanics behind its disguise rely on fringed skin flaps that run along its entire body and jawline. When the gecko settles onto a trunk, it spreads and flattens these fringes against the bark. This mechanism plugs the gap between its body and the wood, completely dissolving any shadow formation along its edges. Its skin shifts color to match the exact pattern of local moss and lichen. By neutralizing depth and shadow, the reptile ceases to look like a three-dimensional object, turning into a flat, two-dimensional painting on the bark. It survives by erasing its own volume from the enemy's perception. But while all these masters of camouflage rely on passive genetics, taking millions of years of evolution to be born resembling their environment, our number one spot ignored the limitations of its own biology. On the ocean floor, this creature uses tactical intelligence and active engineering to build its own disguise in real time. Inhabiting the coral reefs and shallow waters of the Indian and Pacific Oceans, the designer crab claims our number one spot because its survival mode breaks all the established rules of traditional biological evolution. While every other creature on this top 10 relies on passive genetics, born locked into resembling a single environment, this crustacean operates through active behavioral engineering. It doesn't wait for nature to camouflage it, it actively designs and builds its own armor. The mechanics of this animal's survival are purely tactical. The designer crab features a carapace covered in microscopic, curved hooks that function exactly like biological Velcro. Using its front claws, it clips live pieces of sea sponges, toxic algae, hydrozoans, and small pebbles directly from its surroundings and deliberately fastens them onto its back. The most absurd part? If the crab migrates to a different reef where the ecosystem looks entirely different, it strips off its old disguise and redecorates itself from scratch using local materials in a matter of minutes. It survives by hacking the biodiversity around it to become a walking, undetectable piece of marine debris. It is the ultimate master of dynamic camouflage. Our countdown of the planet's most terrifying disguises ends here. If you enjoyed uncovering the hidden engineering behind these creatures' survival, hit that like button and subscribe to support Nature's Top 10. Drop a comment below. If you could have the camouflage superpower of any of these animals in your daily life, which one would you pick? Share this video with that friend who would be blown away by the intelligence of the designer crab, and see you on the next Top Countdown.